Okay, first question asks for the imaginary part of a complex number. And of course the imaginary part is the coefficient of I. So the first thing I would do here is multiply out. So we get 5 root 2 minus 2 root 2I. And therefore the coefficient is the whole thing in front of the I. Therefore it is answer B. Now we're not going to get into too much detail explaining the distractors, but along the lines here for A, I would suggest that all they did was look at the coefficient of I without expanding. Okay. In B, that's obviously the correct answer. In C, they've included the I, which is a mistake. They don't understand what the imaginary part is. In D, they've included the I without expanding. And in E, well, really, no idea. They've just got no idea. No, they've just taken the 2I and not even worried about the sign. Question 2. We now want polar form for 2 root 3 minus 2I. So let's convert first off. So 2 root 3 across, 2 down. So we're in the fourth quadrant. R is the magnitude, so it's the square root of 2 squared and 2 root 3 all squared. So that of course is 4, and that's 4 3s are 12, so it's the square root of 16. Therefore R is 4. Also, we're in the fourth quadrant, so I'm expecting a negative angle. Inverse tan of 2 over 2 root 3, which is 1 over root 3. So that means that the base angle is pi on 6. So in polar form, Z would equal 4 cis negative pi on 6. So the correct response is B. Explaining things, I would reject A and D and state that they are in the wrong quadrants, and you would reject C and E simply because they don't know their exact values. Okay, we're now looking at question 3, where we've got Z1 is 3 cis 2 pi and 3, Z2 is 2/3 cis negative pi and 6, and we're looking to find Z1 times Z2. So Z1 times Z2 is you multiply the two R values together, and then you add the angles. So 2 pi and 3 plus the negative pi and 6. So this cancels down to 2. Cis, so 2 pi and 3 is really what? 4 pi over 6. Take away pi over 6, which means we end up with 2. Cis 3 over 6, which is pi over 2. So the correct option there is B. Now with these, you're going to start mucking around and trying to come up with how they produced the other options. I would say that for A, it looks like they multiplied angles. For C, they added the angles, so 2 pi and 3 plus pi and 6. So C, you just say added angles. For D, it looks like to get 2 over 9, they've divided the R values. So they've done Z2 divided by Z1. And for E, negative pi squared on 9, it's the same response as A, which means they've multiplied the angle and they've also messed up the R values. So that should be enough. Going to question 4 now. Given that Z minus I is a factor, which of the following statements is true? Now, so if Z minus I is a factor, therefore P of I is a solution. Alright, so that means B is true, and you would just state that. Because they're all real coefficients, it means A is true, and you would say that's the conjugate root theorem. C states that there are no real roots. Well, everything's real. You've got two complex factors, so there must be a real root. So C is false. You could actually show what the solution was. D is true because they're linear factors, and that's Z minus I, Z plus I, and Z minus the real number. And E is true as well because we've just shown that there are two complex conjugates. Squeezing in question 5 if we can. We are looking for Z1 divided by Z2. So that would mean you've got 8 divided by 2 because you're dividing the R values. Cis. You then have the first angle minus the second angle, which means we end up with 4 cis. So it'll be pi on 3 plus pi on 4. So that's 4 cis. That's 4, 12, 3, 12. So what have we got? 7 pi on 12. So the option is D. Yeah. A is wrong. Just to write next to yourself while we haven't got room. A is wrong because they've multiplied the angles. B is wrong. It looks like they've done pi on 3 minus pi on 4. They've also got the R value wrong because they've multiplied. C is wrong because they've just subtracted the angles. And E is wrong because they've subtracted the R values. So there's some of the confusing things that people do. They subtract the R values instead of the angles, etc. Okay, we're now looking at 6. We've got an asymptote at x equals -2. That means we must have x plus 2 on the bottom line. We've got an asymptote at x equals 4. That means we have x minus 4 on the bottom line. And we've got the x-axis as an asymptote, therefore y equals 0 is an asymptote, which means there's no whole number. Therefore, A doesn't have these brackets, wrong, incorrect use of asymptotes. B is wrong because it would also have x equals 0 as an asymptote. C is possible, so let's come back to that. C could be possible. D is wrong because if you expand the bottom line, you'll get x squared over x squared minus 2x minus 8, and therefore top and bottom are equal. So if we do long division, we're going to get 1 plus something. That means your asymptote would be 1, and that's wrong because it doesn't match this. And E is also wrong because it has x equals 0 as an additional asymptote. Therefore, C is the correct answer. Going to 7. Whoa, 7 needs a fair bit of work because we're now talking about completing the square. So let's see if I can put this together. So you've got x squared plus 6x, just putting the x's together already, 3y squared minus 12y, and make that equal to 6. Alright, I'm running out of room. So complete the square. You're going to have x squared plus 6x plus 9 minus 9 plus 3 bracket y squared minus 4y. Pulled the 3 out. Now half 4 is 2, so we're going to get plus 4 minus 4 equals 6. That means we've got x plus 3 squared minus 9. Then we've got 3 y minus 2 all squared. That's the perfect square for these three. You're going to get a minus 12 hanging around because you've got the 3 times the negative 4. That equals 6. So we've got x plus 3 squared plus 3y minus 2 squared equals, if you take everything to the other side, you've got 6 plus 12 is 18, 18 plus 9 is 27. So now I'm going to divide everything by 27, so you're going to get x plus 3 squared over 27 plus y minus 2 squared over 9 equals 1. So that matches E. And of course, each of these other options I would explain either they've got the A and B values wrong, or they've got the wrong centers. So each other one could be rejected by wrong center or wrong A or B value. And that's enough to explain question 7. Question 8. Asymptotes. Okay, so let's have a look. X minus 2 squared over 16 minus y squared over 9 equals 1. So the first thing we do is follow the box. Right. So therefore y equals plus or minus the square root of 9, 3, divided by the square root of 16, 4, bracket x minus 2. Let's expand. So we've actually got y equals 3/4 of x minus 6 on 4. We'll fix that in a second. Or you've got y equals negative 3 on 4x plus 6 on 4. Therefore y equals 3/4 of x minus 3 on 2. Y equals negative 3/4 of x plus 3 on 2. And that's option A. Okay. And then we will reject other options. For example, it's reject C, and I would reject C because they've got 4. Anything that's got 4 on 3, I would say that they did A over B instead of B on A. So that would reject D, C, and E. Virtually all those reasons are the same. And then B looks like it's arithmetic mistake.